The quantum mechanical model of the atom. In this tutorial, we will be going over the quantum mechanical model of the atom, principal energy levels, sublevels, orbitals, and orbital shapes. The quantum mechanical model of the atom describes the behavior and the organization of electrons and how electrons determine the chemical and physical properties of the elements. Principal energy levels, represented by the letter N, is the term used in the quantum mechanical model to describe an electron shell. The total number of principal energy levels for an atom of an element corresponds to the number of the period, which we know is 1 through 7, on the periodic table where the particular element is located. The higher the value of N, the more energy the principal energy level possesses. So, for example, if this represented our first shell, where N is equal to 1, we know that first shell, that first principal energy level, has a low energy associated with it in comparison to, 2, 3, 4, 5, 6, where this valence electron is located in the 6th principal energy level. That principal energy level is going to have more energy than the electron in principal energy level number 1. Thus, the principal energy levels located farther away from the nucleus have a higher energy relative to the principal energy levels located closer to the nucleus. Principal energy levels. The maximum number of electrons possible in a period on the periodic table is determined by the relationship 2n squared, where n equals the number, 1 through 7, of the principal energy level. And all of you should recognize this because you were taught this in Regents Chemistry already. The maximum number of electrons possible for any atom of an element in each of the first 4 principal energy levels is described in the table below. So for principal energy level number 1, we know that the formula is 2n squared. So if we substitute a 1 for the n, that's 1 squared is 1 times 2. So the maximum number of electrons is 2. For principal energy level number 2, we'd substitute in a 2 for the n. So 2 squared is 4 times 2. So the maximum number of electrons is 8. And then it's 18, and then it's 32. More detailed information is needed to adequately describe the probable location and relative energy of an electron found within an atom of a specific element on the periodic table. Sublevels. Each principal energy level, otherwise known as an electron shell, is further divided into sublevels, which are sometimes called subshells. The number of sublevels possible within a given principal energy level is equal to the number of the principal energy level, and I'll show you what I mean in a minute. Sublevels are given a letter designation, either S, P, D, or F. So let me explain. So for principal energy level number 1, that has one sublevel, and that sublevel is S. When n is equal to 2, there are 2 possible sublevels, S and P. When n is equal to 3, there is a potential for 3 sublevels, S, P, and D. When n is equal to 4, there is a potential again for 4 sublevels, S, P, D, and F. The pattern observed above for principal energy levels 1 through 4 does not follow for principal energy levels 5, 6, and 7. A method for recalling the order of sublevel filling with increased energy will be discussed in a later video tutorial. Orbitals. Each sublevel is further divided into orbitals. The S, P, D, and F sublevels are divided into 1, 3, 5, and 7 orbitals. Each orbital can hold a maximum of 2 electrons. The s, p, d, and f sublevels are filled with either 2, 6, 10, or 14 electrons. So let me explain. In the s sublevel, there is a maximum of 2 electrons that we see right here. And that's the maximum number of electrons you will ever find in S. Now with P, you have a maximum of 3 orbitals, and each orbital can hold 2 electrons. So this is an orbital, this is an orbital, and this is an orbital. So P is associated with 3 orbitals. Each orbital can hold 2 electrons max. So the maximum number of electrons that you can have in the P sublevel is 6. In the D sublevel has 5 orbitals. 1, 2, 3, 4, 5. The maximum number of electrons per orbital is 2 electrons. So the maximum number of electrons that you can have in the D sublevel is 10. For the F sublevel, the maximum number of orbitals that you can have is 7. 1, 2, 3, 4, 5, 6, 7. Each orbital can only hold 2 electrons. So the maximum number of electrons that can be found in the F sublevel is 14 electrons. An orbital describes the probable location of an electron in the 3-dimensional space. The higher the electron density in a particular region in a 3-dimensional space, the higher the probability of an electron to be located in that region. The lower the electron density in a particular region in a 3-dimensional space, the lower the probability of an electron to be located in that region. Each orbital has a characteristic shape and energy. For the s orbital, this is a sphere-shaped orbital. So for 1s, this is the probable location of an electron. For 2s, we are now a little bit larger. For 3s, we are now a little bit larger than before. And we would see a continuum of this up through 7s. The p orbital is a dumbbell-shaped orbital composed of 2 lobes. There are 3 p orbitals. All p orbitals have the same size and shape, but differ in spatial orientation along the x, y, and z axes. So you can have px, py, and pz. The d and f orbitals have much more complex shapes. So what did you learn in this tutorial? We went over a brief description of the quantum mechanical model of the atom, talked briefly about principal energy levels, which we will be talking about a lot more in detail in the future, defined what a sublevel was, orbitals, and some basic orbital shapes. Need more help? Feel free to contact me. Have a great day.